Recording now.
So, like I said, Dusty Jewett, lead software engineer at Simply Measured, and yeah, that's the talk is refactoring JavaScript. First, about me, I'm weird. I grew up with Flash and Flex, and so like when I started here in Seattle, I was doing Flash and Flex, a little bit of HTML, but mostly that. And so I'm a big fan of having compilers and type checking and performance metrics tools and a lot of things that when I moved into the JavaScript world, it didn't exist. So there's a lot of things that I'm used to, and so not having them in the JavaScript world kind of makes me sad, but there's a lot of tools coming out that help, like with the refactoring and help with figuring stuff out. So it's kind of unusual to meet other, well, not that unusual, but you get a lot of JavaScript people who are like, oh yeah, JavaScript all the time, and it's just all dynamic all the time, and don't understand classes and understand other things, and or care about them. And you don't have to, but I love them. So the compilers, that is. Before I get into why those are important, though, let's take a look at some of the things that Simply Measured does. So the reason why this is important is the work that I was doing at Simply Measured was the JavaScript that rendered this. So this is all SVG here, and it comes in as Excel. And so when I was writing my JavaScript, we would get a big JSON file that was transformed from Excel, and we would have to render it out to the screen every time. So the different kinds of reports, we have 46 different reports. It became really difficult to kind of make sure that if I made one change in one place, it wasn't necessarily making changes and breaking something else. So when I started refactoring, I had to keep this in mind, is that refactoring is just a very disciplined technique for restructuring code. You don't want to change the actual functionality of code when you're refactoring it. So make sure that you're testing a small piece, or like you test a piece, and then you just refactor just that little piece. You don't want to go off and try to eliminate all the bugs and try to destroy like all the different problems that you have when you're refactoring. That's a different process. There's the red green refactor that is talked about in the Rails world a lot. You don't want to do fixing bugs and refactoring at the same time. You also don't want to just burn everything down and start over from scratch. It's always tempting to be like, oh, this is terrible, let's just start over and write everything new. But you don't want to do that. And you don't want to refactor your entire application all at once. You want to pick things that are small core pieces, or if you can't find something that is a small core piece, well, make a small core piece from that larger thing. Break off just a piece of a larger piece and kind of move it over and make it a component. So there are two really great books on refactoring, one for Java and one for Ruby. They're both called Refactoring. They're both written mainly by Martin Fowler. Beck and Fields have quite a bit to do with this one, with the Ruby one. I recommend both of them for people writing JavaScript because there's a lot of good things in both of them that really directly kind of deal with some of the interesting language choices that JavaScript has made. So it's like the Ruby one, you're going to be reading through it, and there's going to be a lot of things that don't necessarily apply, modules and stuff like that. Java stuff, you don't get all the classes and all the fancy other stuff. But there's a good cross between a lot of those interesting bits there. So one of the first things that I always suggest people do is make sure that their build tools are working. It's probably the easiest thing to actually start refactoring. And you might be like, well, but I want to change the way the app works. Well, make sure that it's building fast and it's quick and it's actually building out what you want first. And that'll help you down the line when you actually start refactoring and making changes and making improvements. So there's actually a huge amount of tooling that can help you out. We've got Grunt, Gulp, Broccoli. Those are different tools that can help you out, like repeatably build your code. You've got Yeoman and Ember CLI. Those will help you generate new code, generate like kind of sample starter projects if you're starting new stuff. Make sure that you're kind of just doing things in the standard way for your platform. And then you have, let's see, that's Cordova, thank you. Cordova build and Jenkins. And so being able to build on these systems and kind of get a repeatable build time after time, it'll help you see the progress. After you get those things, then you start looking at how many times do you have jQuery.js in your scripting? How many times do you actually have it locally? What other pieces of code do you have that aren't yours, that are vendor code? Factor those out. Get those from NPM or get them from Bower. There's Ender.js or Jam. There's a lot of different opportunities for you to use package managers. It makes it really easy to upgrade to newer versions of these libraries like jQuery or underscore, different things like that. You can instantly run your tests in underscore, and then you can be like, oh, that's awesome, but now I actually want to use Lodash instead. Being able to switch back and forth can really help out like this. It also makes sure that you get the right dependencies. You don't end up running the wrong version of underscore with backbone. You have this dependency management actually taking care of it. It's something that's pretty new. I say new, but within the last couple of years to the JavaScript ecosystem. A lot of people are like, well, do I need it? But I really think that it is very important. Just not having to track all that information yourself, not having to worry about it. It takes a lot of the thought out of. It lets you focus on your code instead. Also, you're probably going to be hosting your code inside of another app. So whether it's in a Rails app or it's in a Java app, being able to bundle your JavaScript together as one module and put it into Bundler if you have Gem in a box, so that your code is a separate release from an app itself. So if you're writing your JavaScript, it can be tested, it can be worked on independently of the other systems that might be hosting it. It's a really good opportunity to be able to say, look, we can change backends if we want to. We can go from Rails to Sinatra, if we're having trouble scaling Rails. If we need to change database technologies, or all of a sudden we want to go to, a .NET backend. Whatever it is, being able to have your JavaScript out in a separate library will let you use that in different systems. Maybe you just want to spin up a different stack because you have a new product and you want to just reuse your code in this other product. There's a lot of good opportunities for that. So being able to put your code into a repository like Maven or Gem in a box really helps out. And then finally, we've got virtual environments. Virtual environments are really new to the server stack development stuff. So Vagrant and VMware and VirtualBox are amazing. What this lets you do is be able to run the same code in the same way every single time. You don't have to be like, well, are you on Windows? Because this tool doesn't compile in the right way on Windows when you're developing over here versus on the production box, which is running Ubuntu old. You don't run into little things like we're deploying a Sinatra app and Event Machine hasn't been updated in a year and a half and it didn't work on the new version of Ubuntu. You don't run into that because you're actually always running on the same version of whatever the server software is. And you can do that. You can run it quickly. If you're already on a Linux box, you can use Docker and you can set up your own Docker environment and run software in a very controlled environment. So that way, whatever it is that you're running, it's always going to be the same as production. It makes it so much easier when you don't have to debug, well, it worked on my machine. Why doesn't it work in prod? Why doesn't it work on our staging environment? They're always the same. You can use software like Chef or Puppet to automate that. We just started setting up developer cookbooks so that our Vagrant instances run the same exact cookbooks that our production instances do. So it just all gets automatically provisioned and all the software installed automatically. It doesn't take that long to get set up with the simple Vagrant thing. It's literally, I don't know, 5 lines of code to get a box up and running, an Ubuntu box. Really fast and really easy. You can just install software like you want, run history. You can take all your history of that, put it into a script, and just have that provision the box every time you start up. So simple. And then we've got, now that we've got software running repeatably, reliably, you have to start to test it. So the first thing that you want to do when you're refactoring is start looking at what kind of regression tests do you have. What kind of things can you do to really just test the entire thing like all at once? Make sure you're not making a really stupid mistake. So I wrote some software called Zilla that takes just screenshots. Doesn't compare anything else. It just takes a screenshot of before and after, compares them. Doesn't test any kind of code paths or anything. It's just a very simple thing. There's some other regression testing software you can use. The WebDriver stuff can take screenshots. You can use that. There's Phantom CSS, another piece of software. Just taking screenshots of a website is a very simple way of doing regression testing. So at least you can be sure that before it looked like this, after it looks like this. It's kind of the most basic thing you can do. After that, you want to go into integration testing, and then functional and unit testing, and just kind of working your way towards more and more core tiny pieces. But sometimes your code isn't ready to start up doing unit tests, especially if you're coming into a JavaScript project that was set up by a bunch of people who didn't think of themselves as JavaScript developers. So I see this all the time with Rails. You just have a bunch of JavaScript just thrown in, and nobody was really caring about what they were doing. And it worked, but there's no way of testing any of it. There's no way of really being able to separate out this functionality is like this. And so sometimes you have to figure out, where is that line? Where do you make that cut? And so you can't do all of the testing all at once, but you want to work your way down that ladder until you can get to unit testing. So this is an example of kind of one of the charts that we have. It's kind of a simple one, but it's pretty complex as far as like what you might set up when you're in Excel showing to people. So we've got like little guys like this guy. This is actually a separate chart that only has 3 data points on it, but we hide it from the legend. And so there's lots of weird things that we do. And then we get into the really crazy types of charts that we have. And this is the part that really just made my life interesting for a while, is that we have little kind of, our developer or our designer works in Excel, and he is very explicitly kind of tweaking these Excel values to get charts that look visually pleasing. And so while I'm in there mucking around with, the code to try to figure out, this is how I need to make sure that the offset is this or this. We would end up with, this series is offset by 1 whole unit in this kind of chart when it's set up with this kind of data because of something, or some kind of weird bug. I would not be paying attention to this. You can't very well see it even on the board here. It's just this little pleasing type of a thing, but the designer intentionally put that in there when he was designing in Excel. We want to keep that in there. And it's not something that I would notice. As a developer, I'm just like coding away and I'm like, okay, well, all the numbers look right. We're good. But things like visual regression testing can really help with details like that. So the software that I wrote, and there's other software that does this again, will do visual regression testing. So you can see the cursor moves back and forth, and basically I changed the outline here from blue to red, or blue to yellow. And so you can see how did it look before, how did it look after. These types of things can really help out when you know that you need to make a change and you want to make sure that that's the only change that you made. So sometimes you do expect an actual change when you're fixing a bug. And so the visual regression test can help then, and it can help make sure that when you do just a refactor that you didn't change something. And so it helps in both directions. So this, have you guys used Excel? Everybody's used Excel, right? It's the largest programming language in the world. So if you've ever tried to format numbers or anything like that, this is what you get presented with. Look at the size of that scroll bar there. There's literally hundreds of these types of number formatting things in Excel. My job was to make sure that every time we formatted something in the app, it was formatted correctly. So I was presented with this great big problem of just, I have no idea how we format things. I have no idea what kinds of things need to work or aren't working or any of that. So I had this problem. We've got a method that formats things already. It's kind of tied into a lot of things, and I wanted to extract that method out, kind of make it separate. But I had to make sure that I didn't affect the way that we already did things. And so this was a complicated problem. I didn't necessarily know how to approach it for a while. And then I came upon the idea to just have the code write its own tests. So basically, I added a console.log statement in there, and then I had to print out what ends up being valid JavaScript to call this method. And then at the end of the method, I figured out what the result was right before I returned it, and then wrote a strict equal here, which is how I think QUnit was doing it. And so this ended up writing, I bet, about 20,000 lines of test for me. But I would load up every single report that we had in Phantom.js, capture all the console logs for everything, and then take that as my new test framework. So I had 20,000, and I knew that every single time that this code was run in any of our products, I captured what the input and what the output was. So now I could refactor that method and the internals of that method however I wanted to, and I had exactly the specification for what was really going through that method. There was no other documentation as to what should or shouldn't be working. So that's kind of one of the things that I had to do. So one of the things that, like I said, I wanted to capture, to extract this method out by using modules and by using, we're using require.js, but you can use ES6, you can use Browserify, there's a lot of different things that you can use. But by pulling that function out, or those objects out into separate files, you can start to test them separately. So there's a lot of different ways of doing this. If you've got Rails, you can use a / include. If you don't have Rails, you can use preprocessors, you can use Broccoli, you can use a lot of different things to turn your module system into one large system, one large file when you deploy it. But when you're a developer, you want to be looking at smaller files. You want to be looking at things that you can just load into your memory all at once. No more, 5,000 lines of JavaScript in one single file. So by moving to a module pattern, you're going to be able to get a lot of efficiency, because you're going to be able to see, okay, this module here depends on these 3 different modules in this other place. You can start to grep through your code and say, okay, what modules actually depend on this module? You might look at it and find that only one does, and so you know your interface. You know how that code is being used. It can really help you track through the system and being able to figure that out. It can be a little bit of work to move code into a module system. But it's really helpful, because if you've got a very large file and you want to make a change to it, you have to know how every single bit of that file works. So we have a file, unfortunately, in our app still called base.js that has thousands of lines of code in it. And it's so difficult to modify. And we've pulled out a lot of the core functionality out. But like looking through it, you're like, okay, well, what other places call this specific line of code? You know, what kind of string interpretation do they do? What kind of dynamicness is used to figure out what method gets called here? You know, are there weird jQuery listeners tagged on things that end up calling into the code? By using modules, you get to be able to factor that out and identify where you're actually using that. It also lets you be able to track, you know, this is the interactions that these classes have.
So is the situation here where you inherited code and the people who wrote the original code are no more around?
Right.
So that's a situation.
The situation that I found myself in was not necessarily that, but they were on doing other things. Right. And so Aviel, our co-founder, he wrote most of the core JavaScript stuff, but he's off being, you know, vice president of product. He's not going to be able to help me out with why was this jQuery written in this way. In the same way with, you know, we have some other code that's written by people who are now, they're still even in the company, but they're not necessarily coding anymore. So it's a very common thing that I've seen in a lot of startups where, you know, when you're bootstrapping yourself, you're writing code, and you just have to get shit done and get it out the door and you know, fix this one thing before the meeting tomorrow with a specific customer. And it's more important that you get it done than you do it right. But you don't always have time or remember to go back and fix it. I'm fairly certain there was a lot of those moments where we had a little bit of celebration after winning a deal and all of the issues that happened before that were lost. One of the things that by using modules that you get is encapsulation. Encapsulation, in my mind, is kind of the biggest benefit to using module systems. It lets you take methods that aren't being used by anything else and make sure that nothing else really can use those methods. So you might have some really good logic that you want to you know, be asserting, you know, specific things in specific ways, and it's really only intended for this one purpose. You don't want somebody else to come along and see your brilliance and decide that they're going to hijack it and use it somewhere else. You want them to intentionally take this code and put it somewhere else as a module, and you know, and really comment on why they're using it or how they're using it, and know and understand when they do that there's really a reason for it. You don't want accidental or like unintentional usage of things. So the encapsulation stuff is a big thing. I mean, there's the formal capital E encapsulation, which is always good for classes, but this is kind of, you know, specific to the way that JavaScript does it, in that there's almost no real encapsulation. This gives you the ability to do that, and it ends up being really nice. Functional programming in JavaScript is something that has kind of been hyped for a while. Highly recommend this book because if you're a JavaScript developer and you're doing a lot of JavaScript, you will find that you are like 70% towards being a functional programmer. The way that JavaScript treats functions as first-class citizens really kind of enforces that. If you're using underscore or lodash, you're already using a lot of the same code that a functional programmer would use. You might not necessarily be thinking about a problem in a specific way, but you might end up coming up with the same exact answer if you're already using these tools. And so functional programming is really, really, really strong for JavaScript. Can't recommend it enough because it lets you compose very complex ideas and string together different modules in different ways without necessarily having to refactor their internals every time you want to change the way something works. You can just change the way that things are composed and be able to modify things in that way. And so I really highly recommend that. it ends up being a really easy way of just breaking things out into modules. Is just breaking out functions anyways. You might as well just go that extra, like, spend 20 hours reading the book. Well, it's probably more than that, but read the book, spend some time thinking about how to do functional programming. It's got a lot of good concepts. You'll end up writing better code because of it, even if you're not necessarily going to be following functional programming. Also, it's really hard to do classes. They're kind of old school in JavaScript right now. Unless you're using a framework that makes it really simple, like Angular, or I guess, so Ember I think has some classes that you would end up extending. But if you're making them yourself and you have to deal with prototypes and you have to deal with all the bullshit that goes along with it, you're very clever, you're getting a lot of stuff done, and then you hire in somebody new that doesn't understand, you know, how modifying a prototype might affect this other thing. Or, oh no, they just want to extend this class and then change the prototype. They don't realize that changing that prototype ends up changing this other thing. It ends up being a very kind of difficult thing to manage, especially when you're doing it in other people's code, when you don't necessarily have all of the knowledge about how that code was written in the first place. Classes can be a very big opportunity for bugs to creep into the code. And so by breaking things up into smaller things like functions, you can end up kind of saving yourself some of that hassle. You still get a lot of the testing and everything else, but you don't have any of the complexity that goes along with raw classes. If you've got a framework that helps you out, good, use it, do that, absolutely. But I wouldn't recommend trying to do classes on your own and doing prototypal inheritance. Another big piece. Oh yes.
Are you talking about exposing module? You're saying if you're using classes, use it within your module, do whatever you want there, but don't use it where it has to cross the module boundary. Is that what you're?
I would almost recommend not using classes at all.
Okay.
Unless it's really simple for you to do that. I mean, if you're just using a class it's a fairly simple class, and you're not dealing with prototypes, and you're not dealing with any like really complicated structures, it ends up being okay. But as soon as you try to actually inherit from something else, or you want to do something in an object-oriented way, right? As soon as you get a Java programmer in there, they're going to want to, really start doing object-oriented JavaScript, and it just leads to heartache. I really, really wanted classes in JavaScript, and I like some of the new classes stuff that's coming in, the new parts of the language, but we're not going to be able to use that for a long time. So I would just recommend keep classes simple. If you're just going to have, there's some properties, or there's a couple, simple methods on an object, fine, great, that's amazing. But don't do inheritance, don't muck with that, don't muck with the prototype chain. As soon as you find yourself doing that, really take a look at it, because you might have somebody that's really good at this, who really understands all of this. But when you put somebody who is a mid-level or a junior level, and they're kind of maintaining the app and they need to fix one little bug, it's a huge, huge, huge bundle of twine to unravel.
Also, the combination of testing can be immense, right?
Yes.
The prototype. You have to kind of guess a lot of scenarios.
Yes. So yeah, I highly recommend just keeping it a simple constructor, fine. But if you can go with functional to replace some of that, like whenever you need to get complex with some of your parsing, some of your processing, try to go with functional stuff and use composition instead of trying to do a lot of inheritance. Services are amazing, and I'm talking about services in ways to encapsulate your communication with the server. It's really, really good to be able to set up, I think Ember does this through adapters, Angular does this, I think they call them services. But there's ways to encapsulate, this is how I'm talking to my server here. This is how I'm doing this thing. That way you have all of your communication with the service through one piece of code. It makes sure that you're not calling, $.get in 50 million different places. So when you have to upgrade your CSRF tokens, you don't have to worry about that. When you have to change the way you're adding headers to things, you don't have to muck with so many different things everywhere. Encapsulate them into smaller classes, into smaller functions, and really put them in core place. It will let you mock out services. You can do stubbing really easy when you have that type of information. It's amazing to be able to develop your JavaScript application offline without a server running behind it. So being able to stub, being able to mock, being able to do nice verbose logging on every single piece of communication that you have when you're trying to debug, why is my app doing that thing? Why is it showing this when obviously I should be doing this? And identifying every single communication. It makes it really nice and simple to do that. It also makes it easy to worry about, the way that you're deserializing information. If you've got, different kinds of JSON coming back towards you. Server side always likes to kind of do refactoring and make things better. Being able to support multiple endpoints means just build another service, and then you can swap it out as soon as their endpoint changes, and you can just do it nice and easy. That code is located in one place. You don't have to track down every single place that you're calling a specific endpoint in 50 different files. Because now you've got it all in modules, but now it's spread all over. So highly recommend consolidating code into services. And then finally, new technology. As soon as you get all of your, you get everything in services, you get everything nice and tested, you get functional, you're going to want to actually start using more than just Rails and the kind of jQuery type stuff that you get with that, or with the .NET, or whatever else you're doing. You're going to want to start using new technology. One of the each kind of direction that you can go with the new technology has its different good use cases. So I recommend, if you're looking at Angular and you want to try to use Angular, you can start building little micro applications. You can start building little widgets, like if you've got a configurator on your page that does a lot of JavaScript, and if you're building a t-shirt configuration store, you can just build your little widget that figures out all the sizes. Just build that little thing in Angular. You don't have to build everything else. Just build a small little guy. Ember, on the other hand, it likes to have routers. It likes to do full pages. So you might just start off breaking off an entire page and doing that in Ember. So you might end up doing, a piece of your admin page in Ember. So the rest of your code ends up, or you might do your front end in Ember. Whatever customer page, but just pick one single page when you're doing the Ember stuff. It makes it a lot easier. And then React. If you're doing React, React is probably the easiest thing to start adding to any kind of page. You just start building your components. If you're already on Rails, or if you're on Rails, you can do some of the. There's some unobtrusive React stuff that just kind of scans the page for React documented code and just kind of inserts React components right into it. Otherwise, you can just start including React on there, and just the way that you can build React into your page, you can just put a component into it, include React as a file, and your React application will just start working inside of that little micro app. But that's a good way to really start transforming your entire piece. So the functionality might change as far as the code goes, but as far as the user is concerned, you're just taking off little chunks, little pieces of your application, and refactoring in that way. It's probably the only way that I've ever been able to take on and introduce new technologies at companies without having to have like a 6 to 9 month refactor. And it's specifically at startups, it's often something that you can't do. You don't have 6 to 9 months to just throw everything out. So it's really nice to be able to go ahead and change small pieces at a time. Evaluate whether or not it's actually going to help you or help the engineers kind of move forward, because sometimes you might find that it's really not worth it. Maybe the jQuery way is good enough, and you just needed better testing, and you just needed to make sure that you're build process and everything else was solid. But yeah. So with that, it's on your mind. Any questions? Anything else?
What do you guys use to test JavaScript?
We use different things. We are building out an Ember app right now.